Dear student, I told you that you have to very much you have to look at all my assignment. 25 to find out the 25 the symmetry 25 point group from the given examples I have posted to you. Okay, now next topic, that is group multiplication table. Okay, multiplication table. So multiplication table. Okay, so this is a very interesting table. I think I don't know, in the last year you have learned multiplication table for C2V point group or C3 point group. Okay, so I'm just I don't know that you let us take what is the multiplication table means. The operation performed again. So before that I told you group many times. What is the group? So mathematical group means the following characteristics. So group is a set. You can say that it is a set. It is a mathematical so group, or you can say that what I say, set functions, relations, like that. Similarly, it is the group. Okay, so group has the following characteristic. Okay, which is the so sorry, I will continue. I will discuss the mathematical group in your next class. But here I am just giving the group multiplication table. So mathematical group, some mathematical concept I have to explain you. I will explain in the next class. Okay, don't worry. So today, what is the group multiplication table? This is also called group multiplication table. So for example, C2V point group. That is C2V. Let us C2V point group. Okay. One important characteristic of the group is that when you do multiplication among the element should be in the group. Okay, that is C2. Just remember like that only. Okay, that is you take any two element in the group and multiply. The product will be also in the group. Okay, that is C2. What are these symmetry elements? C2 and C2 square, that is E, sigma 1 and sigma 2. Okay, sometimes sigma V1, sigma V2. Okay, sigma 1, I am just taking sigma 1 and sigma 2. Okay, that is water molecule. What I have told you, you take multiplication, that is you perform the one after another, the product will be in the group. That is the characteristic of the group. Mathematical characteristic of the group is that. Okay, so you take C2 and for two I have given you definition. That is, when you do multiplication, you have to get that in the group. Okay, let me take the to proof for this. I'm just I'm writing one table, that is group multiplication table. Okay, that is for that I have to write like this. So E, okay, C2, sigma 1 and sigma 2. These are the so I'm just here also C2, sigma 1 and sigma 2. Okay, then what I have told you, when you do multiplication, the product will be also in the group. That is, you do multiplication among these two elements, the product will be also in the group. So let us see. So I'm taking H1 and H2. Okay, E into E, you do identity operation, again the identity operation, that is E into C2. When you do C2, then you do 360 degree, that is C2, right? That multiplication by identity element, that is called identity element. Okay, so sigma 1 and sigma 2. So again you multiply with C2 into C, that is also C2, this is sigma 1 and this is sigma 2. Okay, now C2 into C2 square, that is E, right? That is E. C2 into sigma 1. Okay, here for this C2, what happens C2? When you do C2, what happens? The oxygen H2 will come here, H1 go here, H1, H2. Okay, then you do what? C2, then next is sigma 1. I have to define this is sigma 1 and this is sigma 2. Okay, so what happened to do sigma 2 here? So from this product I am doing sigma 1 to this product. So I told you I have to define sigma 1, sigma 2 before do the operation. So I am taking the sigma 1 as the two plane. One, this is sigma 1 and this is sigma 2 for this. Okay, sigma v1 and sigma v2. Okay, this is sigma 2, this is sigma 1. So sigma 2, what happened? C2 into sigma 1, C2 then sigma 1. Sigma 1 is this plane. Okay, that is sigma 1 is the C, this is the orientation. Okay, this is the orientation. That is this is sigma 2, right? When you do sigma 2 means H2 will come here, H1 will go here. Okay, so you can say that to be short, for C2V point group, okay, you multiply 2, that is, this is, if you are not able to understand this, I am saying C2 into sigma C2 into sigma 1 will be, next element is sigma 2, right? It is sigma 2. Similarly, C2 into sigma 2, it is sigma 1. Okay, and similarly sigma 1 into C2, you can also try. I will explain you more with this NH3 molecule, right? Okay, this is easy, that's what I don't want to spend much time, it is a shortcut. So sigma 1 into C2, sigma 1 into C2 is sigma 2, okay, and sigma 1 into sigma 1, it is E, and sigma 1 into sigma 2, it is C2. Okay, similarly sigma 2 into C2, it is sigma 1, sigma 2 into sigma 1, that is C2, sigma 2 into sigma 2, it is E. This is the group multiplication table for C2V point group. Okay, you're right, you're fine. Okay, so shortcut is if you are doing with same, that is E. If you are doing with the different, the next element, that is C2. So you take this class as your special class in the Saturday, because I am continuously doing same class. I expect you are watching this class after doing the exercise. Okay, now group multiplication table for NH3. NH3. This is not that much easy. Okay, group multiplication table for NH3. So what are it is C3V, right? So what are the symmetry elements? Symmetry elements, C3 square, C3 cube, that is E. Okay, then sigma 1, sigma 2, sigma 3. Okay, right. So I told you I'm writing my NH3 molecules, H1, H2 and H3. Okay, and this is your initial molecule. Okay, so again what you have to do, you have to do the table like this. Okay, C3 square. So for the second, little space here. C3 E, C3 square, sigma 1, sigma 2, sigma 3. So similarly I'm writing here also E, C3 square, sigma 1, sigma 2, sigma 3. Okay, so I hope everything is visible in your video. I just want to also write small because I have to do a lot of operation. H1, H2, H3. Okay, so I told you 3 sigma V's are there. Sigma V1 means, okay, sigma V1 means the plane which passes through the H1. Sigma 2 means plane which passes through the H2, and sigma 3 plane which passes through H3. Okay, C3. Okay, C3 I am taking like this. Okay, C3. First, okay, C3. Let me tell you one more thing. Sometime you also may be confused with some examples. The C3 minus 1. What is that? What is that? It is what is the inverse? That is, you rotate like this. That is, so this is, you suppose your degree of the clockwise rotation. Okay, this is your anti-clockwise direction. That is sigma minus 1. That is, when you do C3, what happen? H2 will be here. Okay, H1 is here, and H3 will be here. Okay, again you do C3, that is C3 square. What happen? H1 be here, H2 will be here, H3 will be here. Okay, H3 will be here, right? So okay, right, C3 square. When you do just reverse of this, that is C minus 1, that is, this is C3 1, right? Okay, this is C3 minus 1. This is rotation in this direction. What is that? So H1 will be here, right? H3 will be here, H2 will be here. That is the same thing. That is, generally I can tell you that for a Cn, okay, Cn n raised to minus 1 is c minus 1, cn minus 1. Got it? cn minus 1 is cn minus 1. That is c3 square. That is what? c3 raised to minus 3 minus 1. 3. c3 square means what? c3 square means c3 minus 1, 3 minus 1, right? This is that is what? C minus 1. That is similarly c4. So c4 raised to 3 is c4 minus 1. That is c4 minus 1. Okay, so inverse. Okay, that is, so you can note down this point here also. Okay, forget about that. That is what I mean. This is, I think, I hope you got it. Now forget that. Now come to here itself. Now what? E into E, that is E. E into C3, that is C3. E into C3 square, that is C3 square, right? You do with any operation. So all the product is in the group. Okay. So similarly C3 square, sigma 1, sigma 2, sigma 3. Right? Now C3 into C3, that is C3 square. C3 square is a element in the group. Follow, right? It is following. Okay. C3 into C3 square. C3 into C3 square means it is C3 cube, that is E. And C3 into sigma, that is difficult. Let us see C3. This is your C3, right? This is your C3. Now what you have to do? Now you have to do sigma 1. I told you what is sigma 1. Initially I have put the sigma 1 as the plane which is passes through the h1, which belongs to h1, which is plane. So now you do C3 into sigma 1. Okay, C3 into sigma 1. That is, I am putting h1 as it is and reflect it. Reflect means h1, h2 position is h3. This is h3. This is h1. Sorry, h2. What is that? What is that? Is it how you do shortcut? Where this is your initial. I told this is your initial. So you can see that h3 position is same. H3 position is same. Okay, h3 position. See, I told you, even it seems to be just tilted, but it is actually. So all symmetry operations are look alike. Okay, h3 position is unchanged, and h1 position and h2 positions are interchanged, right? So h1 position is in the h2 and like that. So what is that? You can say that h1 position is, so it is sigma 3, right? This new operation, this is new operation product after doing two operation, C3 and sigma 1, that is C3 and sigma 1. So after two operation, consecutive operation, it product is, it is sigma 3. It is sigma 3. So how you look? Like this. Similarly, C3 into sigma 2. So this is your C3. From here to C3, then you do sigma 2, right? That is sigma 2 means the the H1 position is unchanged and the H1 and H3 position is interchanged. That is n H1 H2, it is your H3, this is your H1. So what? H1 and H3 interchanged. That is this is interchanged. So now look at from the initial, what happened? H1 position is same. H1 position is same. That is, and the H3n, it is sigma. It is sigma 1. It is sigma 1. One more shortcut is there. See, all operation will give the all product. Okay, it should be belongs. So all sigma 3, it should be sigma 2. You can check it again. Okay, and let me tell you, sigma 1 into sigma 2 is not sigma 2 into sigma 1. Okay, let us look at C3 square. I told you this is, I'm really sorry, I have small board. So C3 square. So this is here. Again you do C3. That is n h. So h. This is your C3 and this is your C3 square, right? So do again rotation. H2 position will be here. H3 position is here. H1 position is here. It is difficult, but dear student, you have to do these things. So I think I have some of you might have done these things in your BSc classes. If you, then it is easy, otherwise some difficult. Okay, so I hope some of you have not done in your BSc for that, or you may forget it. So C3 square, this is your C3 square. From here you have to do C3 square. This is your C3 square into C3, that is E, right? C3 cube is E. C3 square into C3 square, that is C3's, okay, again C3 raised to 4. So here also you can rewrite like this, C3 raised to 3 into C3, right? That is, this is E into C3. E into C3 means C3. E identity element into any operation is that C3, that is, it is C3 raised to 4 is C3. And C3 square into sigma 1. Then you have to do here. Okay. Here, suppose sigma 1, right? Sigma 1. That is, this is your C3 square. This is your initial. You keep it in your box, and it should be there till last column is filled. Okay, this is very important. Otherwise, everything will be wrongly placed. Okay, so C3 square into sigma 1. Into sigma 1. Sigma 1 means which is reflection along the H1. So H3, that is easy. Your H1, keep it here, H2 here, and H1, H3 here. Now you compare with your, so it is H2 position is not changed. That is, it is sigma 2. Okay, and let me similarly for some time fan. Similarly, next C3 square into sigma 2. So your this is your C2, and you do sigma 2. Let me do it. Let me do it here itself. Okay, let me do it here. Sigma 2. What is that? That is, you keep H2 position is as it is, and H1 position and H3 position are interchanged. So you compare with it. So H3. So I think you have difficulty. So H3 position is unchanged, and that is it is sigma 3. Next, which is left? C3 square E sigma, then it is sigma 1. Okay. Similarly, next sigma 1 into C3. That is not sigma 3 into C1. Sigma. Okay, this is. So I am starting from here. Both are different. Okay. For example, sigma 1 into C3. That is C3 into sigma 1. That let us see what same or not. Same or not. So what you have to do? You have to start from here. You have to start from here. Okay. You have to start from here. That is, I think, no use of this. Okay. This is okay. I'm just erasing all this. Now we have. Okay. First one. Sigma 1 into sigma 1. What happens sigma 1? That is sigma 1 means H position is there, it is, and H2 and H3 position is interchanged. Okay. Next is sigma 1. There is sigma 1 into C3. Now you do C3. What happened? Rotate. That is do rotation. That is H3 position will be here, and H2 position will be here, and H1 position is here on rotation. Okay. So product is compare with this whether any position is as it is. Okay, 1 minute. H1. Okay. H1, H2, all H2. Okay. Right. What is that? Sigma 1 into, right? Sigma C3. Okay. How you do this? Is it C3 square? C3. H1 is there. H1 is here. C3 square, I think it is. This C3 square, right? No. It is sigma 3, right? Sigma 3 is there. Sigma 3. It is sigma 3. So you look at here. C3 into sigma 1 is okay. At sigma 1. Oh, here it is wrong. That is the confusion. That is that. Look at one minute changes will. So H1. So when you do reflection, it is here. This is your H2. This is your H3. Now do the rotation C3. H3 position is changed here. H2 position. H1 is correct. Is it C3? No, it is C3. It is C3 square, right? C3 square. H1 is here. So no. Sigma. It is sigma 3. It is sigma 3. Okay, correct. Sigma 3. Now sigma 1 into. Okay. So now sigma 1 into C3 square. So what is the C3? We need C3 here. H1, H2, C3 square. This is C3 and this is C3 square. Okay, hello. So don't forget sigma 1 into sigma 1 into C3 square. Okay, so what is that? Sigma 1 into C3 square. Sigma 1 then C3 square, that is C3 okay, one more C3 square, that is so C3 square, that is okay, sigma 1 into C3 square, so it is C3, then C3 square will be the H1 will be here, H3 will be here, and H2 will be here. So it is you compare it with your initial one, so it is sigma 2, it is sigma 2, and sigma 1 into sigma 2, sigma 1 into sigma 2, sigma 1 into sigma 2, it is sigma 1 do sigma 1 you have done, then sigma 2, that is you keep H2 here and H1 here and H3 here. So what you got, you compare it with, is it nothing, no position is similar with respect to each other, so I can that is it C3, it is C3, right, it is C3, and sigma 1 into sigma 2, sigma 1 into sigma 2, so do sigma 2 here, sigma 2, that is sigma 1 into sigma 1, right, this is sigma 1 into sigma 1, that is E, sigma 1 into sigma 2, that is it is sigma 1 into sigma 2, that is it is C3. Okay, next one will be sigma 1 into sigma 3, so sigma 3, so sigma 3, that is H3 you keep there, then H1 and H2, so it is C3 square. Again you do sigma 2 into, you have to do sigma 2 from initial. Okay, sigma 2 into, okay, you can write like this, sigma 2 into sigma 2, it is E, sigma 2 into, first you do sigma 2, sigma 2 means you keep H2 there itself, and H3, H1, sigma 2, then sigma 2, then C3, that is H2 will be here, H3, H1, H2, H3. So you compare it with any number, H1, H3, so it is I think it is C3 square then. C3 sigma 2 into right, and C3 and H2, H3 here, H1 there. So it will be C3 square, right? C3 square, C3 H1, H2, H2 is C3 square. Okay, and sigma 2 into sigma H, 1 minute, sigma 2 to position same, H3 change. Now C3 to C3 rotate, that is a H2 here, H3 there, H1 there. So it is it C3 square? C3 square to C3 H3 H1 H2 H3 H1, somewhere it is problematic. Sigma 2 H1 here, H3 there. This is not proper. Here H2, this is not, nothing has done. 1 minute, sorry for mistake. Sigma 2 means H2 here is H1 and it is H3. Okay, now sigma 2, this is sigma 2 into E, okay, sigma 2 into C3, sigma 2 into C3 means H3 there, H2 here, H1 here. Okay, it is H3, H1. So it is sigma 1, right? This is sigma 2 into, it is sigma 1. Okay, and following me, right? Sigma 2 into C3 square. C3 had one more C3, that is H3 here, H1, H3 here, H2 here, it is sigma 3. Now sigma 2 into sigma 1, that is N H1, H3 here, H2 there, sigma 2. Sigma 2 into sigma 1, sigma 2 into sigma 1, sigma 2 into sigma 1. So it is okay. It is it C3 square? Is C3 square, right? So it will be C3, right? Okay. And now again C3 sigma 3 sigma 3 H1 H2. Okay, sigma 3 into C3 sigma 3 into C3, that is H1 H3 H2. Okay, rotate, all position is changed. That is sigma 3 into C3, it is sigma 2. Okay, and sigma 3 into sigma 3 square, do again C3, that is and H3 here, H2 here, H1 there, that is it is H3 here, H3 there, H2 here, H1 here. So it is is it sigma 1? Okay, it is sigma 1. Okay, sigma 3 into sigma 3 into sigma 1, 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 sigma 1, that is H1 position is same, and H1 position is H3 position, H2 position. So it is so sigma 3, okay, H1 H2 H3, okay, H1 so sigma 1 and sigma 2, sigma 1 we did. Okay, it is it C3 okay, C3, it is C3, right? Okay, rotate it this one. Okay, it is C3, it is sigma 3, it is C3 square. So this is the group multiplication table for C3 point group. Okay, so at least you try to understand. Similarly, you can do C4V. You try yourself to find out the group multiplication table for C4V.